Hello, and welcome to the Level 2 Inorganic Laboratory instructional video for the synthesis and reactivity of ferrocene. In this video we will be looking at the acetylation of ferrocene step of the experiment. To begin with, heat a water bath to boiling. While the water is heating, prepare a calcium chloride drying tube. To construct the drying tube, first pack cotton wool into one end of the tube, next fill the tube with calcium chloride granules, and then secure the end with some more cotton wool. In a 50 ml round bottom flask, weigh out 0.25 grams of ferrocene. Once the water bath is boiling, add 5 ml of acetic anhydride to the ferrocene. Finally, add 0.25 cm cubed orthophosphoric acid dropwise with constant stirring. Add a Teflon coated magnetic stirrer into the solution, place the pre-prepared drying tube on top and heat in the boiling water bath for 10 minutes. After 10 minutes of heating, cool the solution thoroughly in an ice bath, disconnecting the drying tube and adding 1 cm cubed of ice water dropwise with constant stirring. After this, add approximately 10 grams of ice. Test the pH of the mixture and add 1 cm cubed portions of 4 molar sodium hydroxide until the mixture is neutral. Extract the ferrocene derivatives from the aqueous solution using 2 times 10 cm cubed portions of ethyl acetate. Wash the organic layer with 3 times 10 cm cubed portions of water. Dry the organic layer using anhydrous magnesium sulfate and filter using gravity filtration. Retain a 1 cm cubed sample needed for the thin layer chromatography analysis later in the experiment. Remove the bulk of the solvent using a rotary evaporator, leaving 1 cm cubed of the solvent behind. The ferrocene derivatives will be separated via column chromatography. To begin with, the solvent for the system needs to be determined using TLC. To do this, spot a small amount of your reaction mixture, a small amount of the starting material, and a combined spot of both onto a TLC plate. Do this testing for all of the solvent ratios, 8:2, 7:3, 6:4, and 1:1. These will be by volume of 4060 petroleum ether ethyl acetate. The solvent that will be used is the one that best separates the ferrocene derivatives. The column will be packed using the slurry method. If your column does not have a sinter, it will first need to be plugged with glass wool, then covered by sand. Add your determined solvent to 15 to 20 grams of silica gel to produce the slurry. Add the slurry to the column. Once the silica is settled down to 15 cm, run the solvent down to the top of the silica. Add 0.5 to 1 cm of sand to protect the column. Make sure the silica and sand are flat, as this will affect the separation process. Use a pipette to add your acetylated ferrocene evenly over the top of the column. If necessary, you can dissolve the acetylated ferrocenes in a very small amount of ethyl acetate, 0.25 cm cubed maximum. Repeat this until all of the soluble compounds have been transferred to the column. Run the level of the liquid down to the top of the column to load your compounds onto the silica. Use a pipette to carefully add the solvent to the column, taking great care not to disrupt the sand, as this will affect the separation. If the solvent becomes coloured, stop adding solvent and run the column until almost dry, then add the solvent again until full. Steadily run the solvent through the column, remembering to keep the solvent level topped up. This should slowly cause the separation of your product, resulting in distinctive separate bands. As the first band reaches the bottom of your column, start collecting the fractions in test tubes. After the first 2 fractions have been collected, you can increase the polarity of the solvent in order to speed up the process collection of the final fractions. Once you have collected all of your separated acetylated ferrocene into fractions, spot a sample of each one onto a large TLC plate in order to determine which band is in each fraction. Combine the fractions containing the same band, discarding any fraction which has 2 bands present. Remove the solvent from each combined fraction using a rotary evaporator to give the individual products. For each compound, obtain the mass, melting point, proton NMR and IR spectrums. Obtain IR of the carbonyl region as a solution phase IR in dichloromethane using a solution cell. This concludes the acetylation of ferrocene stage of the experiment.